Sometimes I feel like science is moving so fast, like it's almost impossible to keep up.
It is pretty incredible, isn't it?
It really is. And today we're diving into a topic that's about as cutting edge as it gets. Particle physics.
Right at the bleeding edge.
Exactly. Buckle up, everyone, because we're about to go on a deep dive into the world of particle physics and something called, get this, shower deconstruction.
Catchy, right?
It definitely grabs your attention. So we've got some research for this deep dive, and honestly, even the title sounds intimidating. Something like interpretable deep learning models.
Yeah, that's a mouthful.
It really is. So before we get too lost in the jargon, can you give us the layman's explanation? What's so groundbreaking about this research?
Okay, so imagine, imagine you're trying to understand how fireworks work, right? But instead of seeing the whole show, you only had a snapshot at the very end, just a jumble of lights.
Okay, I'm picturing it.
That's kind of what physicists are dealing with at the Large Hadron Collider. They smash these tiny particles together and create a shower of new particles. And this research, it's all about figuring out how to rewind that explosion, how to trace those particles back to the very moment of impact.
So like a microscopic car crash investigation.
Exactly, except we're talking about events billions of times smaller than an atom.
Okay, that's where I start to lose my grasp on things.
Mhm.
I mean, how can they even see something that small, let alone figure out where it came from and where it went?
It is wild, isn't it? And the truth is, there are like almost infinite paths these particles could take, and that's where the deep learning part comes in.
Okay, hold on. Deep learning. Like AI. Are we already bringing artificial intelligence into particle physics?
It's the future. Think of it like this, like trying to navigate through a city with thousands of streets. You could try every single route.
That would take forever.
Right. But what if you had a navigation app that instantly showed you the best path?
Okay, that's starting to make sense.
Huh.
So this AI, it's finding the most likely path for the particles.
You got it. It uses something called a Markov decision process to basically eliminate all the wrong turns and dead ends.
Markov decision process, and
Right.
that's what the AI uses to, like, find its way through the particle maze.
Exactly. It learns from each collision, figuring out the most likely paths based on the data.
So we're basically training AI to be particle physics detectives.
You could say that. And the crazy part is it actually works.
This is blowing my mind.
And it's not just about finding the paths, it's about understanding the rules, like imagine giving this AI a crash course in physics, all those fundamental laws.
Standard model, right.
Yeah, exactly. We're basically letting it loose in the data to see if it can like connect the dots, find the hidden patterns.
Okay, but that brings up another question. Why go through all this trouble? I mean, these collisions, they happen in a fraction of a second, billions of times smaller than an atom. Why do we even care about the exact sequence of events?
Well, that's the million-dollar question, isn't it? It's because by understanding these collisions, we can unlock some of the biggest mysteries of the universe, like dark matter, for example.
Dark matter, that's like the visible stuff that makes up a huge chunk of the universe, right?
Exactly, and we have no idea what it is. But some theories suggest that new particles we haven't even discovered yet, might be created in these collisions. And those particles, they could hold the key to understanding dark matter.
So you're saying this AlphaPS, it could help us find evidence for dark matter.
It's possible, but it's not just about finding new particles either. It's about, like, pushing the boundaries of our understanding. The standard model, it's great, don't get me wrong, but it doesn't explain everything. There are still gaps in our knowledge,
So we're talking about potentially rewriting the textbooks on physics here.
Potentially, yeah. And that's what's so exciting about this research. With AlphaPS, we can analyze these collisions so much faster with so much more precision. It's like having a super-powered magnifying glass for the subatomic world.
It's incredible. So faster analysis, more data, which could lead to some pretty groundbreaking discoveries. But it makes you wonder, I mean, can this AI really replace the intuition of a human physicist?
That's a great question. And the answer is, not yet. At least not entirely.
So it's more like a partnership.
Exactly.
Yeah.
Physicists provide the framework, the questions we want to answer, and the AI, it helps us sift through the mountains of data to find those answers. It's like a collaboration.
That makes a lot of sense. But I have to ask, how do we even know if this AI is giving us the right answers? I mean, it all seems so complex.
Well, that's where the interpretable part comes in. The researchers have designed AlphaPS so that it doesn't just spit out an answer. It shows its work.
Shows its work. Like in math class.
Exactly. We can actually look under the hood and see how it arrived at its conclusions.
Okay, so it's not just a black box. There's a level of transparency there, so physicists can understand and verify the results.
Exactly.
Yeah.
And that transparency, it's crucial. It builds trust in the system.
That makes me feel a lot better about all of this. So it's not just about finding answers faster, it's about making sure those answers are accurate and meaningful.
Now you're getting it.
This is really fascinating stuff. But I want to zoom out for a second. For those of us who aren't particle physicists, why does any of this matter? What's the big takeaway here?
I know it's easy to get lost in the weeds with all this stuff, but at the end of the day, it's really about pushing the boundaries of what we know, those big questions like what is the universe even made of? What are the rules?
We're talking about more than just the tiny particles, right? It's about the whole universe.
Exactly. Every new particle, every little interaction we see, it brings us closer to understanding the big picture.
And AlphaPS, this AI, it can help us uncover those secrets faster than we ever could before.
Way faster. This is opening up a whole new world of possibilities. Imagine analyzing data in real time, making adjustments on the fly, It's incredible.
It's like we're having a conversation with the universe itself.
That's a great way to put it. And who knows what we'll find? I mean, think about it. Understanding electricity and magnetism led to, computers and smartphones. Imagine the possibilities when we unlock the secrets of particle physics.
New technologies, new ways of thinking, the possibilities are endless.
Exactly. This is bigger than just physics. It's about human ingenuity, pushing the limits of what we thought was possible.
This deep dive has been incredible. Honestly, I'm blown away by all of this.
It's pretty mind-blowing stuff.
It really is. And you know what? You don't need to be a physicist to appreciate it. It's about the thrill of discovery, right?
Exactly. Never stop asking those big questions. Never lose that curiosity.
So to everyone listening, keep exploring, keep learning. You never know what you might discover. This is The Deep Dive, signing off.